Hello all, welcome to another video in the series of discrete mathematics. And in the previous video I was discussing about the finite automata, and which is the next topic after I discussed some certain relations and all, right? So in the alphabets, I have discussed the alphabet, then I talked about the string and strings and substrings, and the prefix and suffix of a string. If you have not watched those video, you can refer to the playlist of discrete mathematics. And now, without wasting a minute, we are going to start. I'm going to start with the next topic, which is language, right? So language, as we know the alphabet, so language is nothing but a subset of the combination of all the alphabets. So it can be right. The definition will be a language L. A language L is a subset of alphabet star, right? And what is the meaning of alphabet star? Alphabet star is nothing but the collection of all the strings, right? Collection of, it represents the collection of strings, right? Collection of strings over what? Over itself. This is what is this? This symbol is alphabet, over alphabet. So any alphabet is given to you, right? So the language will be a string or collection of strings. For example, and for example, if this is a language, which is this, the combination, right? Yeah, or the collection or the combination of alphabets. So if I have two symbols, this a comma b, which is alphabet, right? And so the language will be, which I am denoting as L1. So it will be a, right? It will be b, it can be aa, it can be ab, it can be ba, it can be bb, or all the languages which can be made with this. Because and it also includes the empty string, which is nothing but the epsilon, right? So a language is, it can be of length 0, length 0. These two are of length 1. These four are of length 2. And we can make or we can generate the strings of length 3, length 4, length 5, length 6, length 7, and up to the infinity. So that's why the definition of language is nothing but it is a collection of strings over some alphabet, right? Likewise, we can take another example, like this is L2, and so a language over some alphabet 0, 1. It can be again of length 0, which is denoted by epsilon. It can be length 1. It can be of length 2, right? It can be of length 3, right? It can be of length 4. So all the languages which can be generated from this alphabet is known as, or all the strings which can be generated from this alphabet or any alphabet which is given is known as a language. So that's why in the definition they are saying that language is nothing but the collection of strings. So now we move to the important topic, right? We move to the important topic related to language, which is clean closure. So there are many questions and they ask in your exams from this topic, which is clean closure. So what is clean closure is very important to understand this topic from exam point of view, and it will it's going to be very important as to two to three questions are from this only this topic, but it can be understood if you have clear concept of alphabets, strings, and languages. So the clean closure is says that let L be a language over a alphabet. Let B language let L be a language over some alphabet. Alphabet is represented by this symbol, right? Then clean closure will be then clean closure which is denoted by L star will be the set of all the languages or all the words, okay, all the words, right? So we can see that L star is nothing but the set of all words, set of all words, set of all words over some language, over some alphabet, sorry. So set of all words means that the words of length 0, right, words of length 1, 2, 3 and so on, right? So if we combine all these words that can be generated of any length from some alphabet, so we will say that clean closure will be the combination or the set of all this. So I will denote it as, or as it is given in your book also, that L0 is denoted as the language or the set of all the words, all the strings of length 0. Set of all strings of length 1 is denoted by L1. Set of all strings of length 2 is denoted as L to the power 2, and so on. For the length of 3 words, it denoted as L3 and so on. So clean closure L star is the union or of all these languages. So that's why I was saying that you must have the clear concept of language, right? So this is your clean closure. So this is your clean closure. It is also denoted as union of, let's say, some symbol k to 0 to infinity, because these are the combinations of all the languages starting from 0 to infinite. So that's why I have written k to 0 to infinite. So that means the k will be here, right? So k is nothing but your power, but this is nothing but your strings. So these strings are raised to power k. It can be written as this, right? Okay. Now, for example, because from examples we understood very clearly, right? So we have some alphabet which is this A comma B, and they are saying that a language L over this alphabet, right? For example, this they have given you that L is a language over alphabet, and alphabet defined as it contains only the two symbols A and B. So you have to find the clean closure L star. So to attempt this question, this type of questions, first of all you have to write the L star as expanded L0 union L1 union L2 like this, right? You don't need to be right till L raised to power 100, okay? So just write 2 to 3 terms that you can easily generate the languages over these, right? Now write this language L0, right? So L0 is nothing but your empty string which contains only epsilon. L1 which is of length 1, so length 1 string can be generated A and B only. It can be A comma B. Then of length 2 it will be what, A, it can be A B, it can be B A and B B, because you know that we have two symbols, and we have how many words or how many strings we can make or we can generate using these two symbols, which is 2 raised to power 2, which is 4. So if I take these two symbols and the combination of these symbols of length 3, it will be 8, right? So you can also generate for L3, but I think there is no need to calculate. If they ask you in your exams that what will be the L raised to power 3 over some alphabet A comma B or 0 comma 1 or 1 comma 2 or whatever the alphabet they given, or they ask you this type of questions, so only then you have to calculate it, right, further, otherwise no need to calculate. So now what I want to say is that this is incomplete because we have to put all these strings into this formula, right? So this is like formula L star as your L0 which is empty string, union of this, union means that will be in a you can say that a superset, right? So A comma B, right? And then union of L2 which is nothing but the set of all strings of length 2. So it will be A B and B and so on. So this is the clean closure, closure clean closure of alphabets A comma alphabet is one but containing two symbols A comma B. So in that way you can find the clean closure of any of the problem. So I gave you some questions, right? I give you some questions, you can write in the message box that if I have this symbol which is 0 comma 1, can you write the language L3, right? So can you write this? So tell me the answer, okay? I will wait for the answers. Thank you very much, and in the next video I'm going to explain you the concept of deterministic finite automata and deterministic finite machines, in which I will discuss the differences between the Mealy and Murray machine, which is again the DFA or finite machines, right? So this is the part 2, and in the next part, which will be part 3 of in the series of this finite automata, all the important topics will be covered. So thanks for watching.